Hello everyone, welcome to another stream. Supposed to be live. So, last stream, we basically getting this soil material looking kind of okay. I kind of come up with this one. It's got some sliders and things as well. So you can bring up the debug sliders and change some things. Get which ones it is now here. So this is like the clumpiness for some clumps basically. And then there's some other ones. That's like a wetness. Not that good, that one. And yeah, basically, I think. But yeah, it looks all right. So the conclusion that I came to last stream is effectively we've been doing a bunch of research and development, if you will, on how we should do 3D materials, right? This is just a sphere, and then we're taking the sphere local space coordinate and then using that as a UV inside a 3D space of -1 to 1 and simply sampling inside a texture, a 3D texture which is procedurally sampled through code basically. It's not a texture stored in memory, it's all procedurally made through code. So, hey there JD House, welcome sir, how are you doing? Correct me if I'm wrong, but I thought you were going on holiday. No, that was yeah, I'm not going on holiday for another week. That's what the post was about. 10th to 17th of May is when I'm going on holiday. So it's actually starting the week after. Sorry. Not this weekend, but the weekend after on the Sunday I'll be going. So I won't be streaming from Sunday the 10th. And I won't be streaming on the 17th either, but the one after that I'll be. Yep. Don't worry about it. But yeah, so basically I've come to the conclusion of like what this research and development has been about. And, you know, I've been thinking about the material work and what I've learned over the past so many streams on 3D procedural materials. So we did have a way of doing ray marching inside of volumes. So if we go back to some of the other stuff, we had a brick one, right, where we just drew a box and then we had -1 to 1 on the UV, mapped it into -1 to 1 UV space. And essentially there's an SDF inside this for like a brick surface basically, so we'll ray march into it. And that was what was going to be called a geometry material. But then as soon as you did that, you basically, if you wanted to like blend different layers of materials together, you could do multiple ray traced materials, so ray march materials, but then you'd basically just pick which one was closest, kind of thing. So if you wanted to maybe spawn another object on there, you'd have to basically have an acceleration structure where you basically store a bunch of different spheres or whatever, or boxes inside this thing. And as you're ray marching, you'll be ray tracing against these things as well. And if you hit one of these, you'll step into it and then ray trace or ray march into those objects which are inside those spheres. So you could, for instance, spawn bits of moss or something like that. So this was some solution I was thinking of if we was going to have 3D ray marchable materials. And then if you wanted to say just change a color of something by painting over it, again, you just spawn spheres down and have those as some ray traced acceleration thing and blah, 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 blah. But that came with many problems, right? It's quite complicated and yeah, so you know, it seemed like a good idea at the start doing ray marching, but it came with a problem where layering needed some kind of acceleration structure with spheres and material space. since the surface is no longer where the triangle surface is, right? So we couldn't simply just, here's where the triangle surface is, right? You couldn't like just stick in here like, hey, on this face of the triangle, it just uses these 4 different materials, because there's like 4 different materials or whatever, right? So 0, 1, 2, 3. But then you can do that because you could be going through this triangle over here, right? And you could just go to the right place. Let me use a line. You could be going through this triangle here and you hit the surface over here or something like that. And oh, sorry, the surface is down here, isn't it? And you actually need to get the material layers from these triangles up here. But then how do you do that? Right, you have to do some sort of lookup on the triangles, which is kind of crazy. So you'd have to store it inside the space because you can just get it at those triangles. So it could actually be close to another triangle on the other side of the mesh, given the right camera angle. So we also had another potential issue with the 4-layer order-independent transparency buffer. So we were heavily reliant on the fact there's empty space pixels, right? If you hit the box, so you render the box into like a visibility buffer with 4 layers. If you have many of these boxes lined up where you keep missing some pixels, you end up just rendering the sky because you've not got anything you've actually hit in the final shading pass. So that was the problem with the ray. Those were the problems with the ray marching. It seemed cool at first, and it seemed like kind of a no-brainer. But when we dug deep into it, it had problems to be solved. Parallax occlusion mapping also seemed reasonable. I did that before the ray marching. It's just a cheaper version of the ray marching. But it had clear visual artifacts, hence why I switched to try and ray marching. So parallax occlusion mapping is obviously in 2D, right? So the final approach, which is the simplest, and the one I kind of avoided because I was trying to get extra detail, and I thought the best way to do that would be some height map based thing, parallax occlusion map or ray march. But it seems like we're just gonna go with a simple approach, which is just generating a 3D or 2D texture procedurally with noise. This works best because we can have many layers in triangles and simply blend them together. But we won't be able to make something like a brick material that we made in the first place. But instead we'll have to make a material for a single brick, but not a brick wall. And we'll just have to make bricks out of procedural geometry instead. So that's the takeaways from the material work. At least we've done the research now and done the, understand the problem a lot more. So we know that this simple solution which has been picked is the right one. So I was thinking we can clean up the material code, get rid of the ray march and detail materials, just have a solid and a soil material, and get material layers working. It should be quite easy to do that. I was thinking about doing this like opaque render pass thing and 4-layer order independent transparency for renders, but I think we'll come back to this stuff later. SDF to mesh system as well. We'll do that later. So we can do this, but then it just means that it takes more time. And I posted something else the other day. Get up the it was on this one. So I was praying the other day because all this material work left me felt been a bit, bit confused basically, right? And I was kind of like I lost my direction. We got answers for a material system, which was cool, but trying to move on to doing some mesh work soon. This was my idea. So imagine like I've gone down in the weeds in the mesh in the material system, and I'm coming back up now, kind of thinking like where was I going next? So it would be right to move on to the mesh system. I did a proper mesh system basically, right? But I'm still really lacking some overall direction for a game idea, and I feel like if I just keep going doing this, where I keep going down in the weeds and up again, down in the weeds and up again, it's going to be probably making lots of stuff which I might not actually use, right? Obviously, I need this material thing, and obviously I need a mesh thing, right? But we could probably cut some work out if we had more of a game idea of what we're doing. So I asked the Lord yesterday, in the car for a simple game idea that would be fun for Christians, but also not for Christians, right? Because what's the point of making content just for a Christian to consume? Ideally, you want to have it for a wider audience, right? But I really don't want to hold back on it also being good for a Christian to play, right? On that to be taken out of the equation. So anyway, I pray to God about it, and the Lord provides. So yeah, so I've been writing up this document. I'm not really gonna say what it is just yet, but come to the conclusion with some people acknowledging it's probably the right way to go. So we should probably skip doing a proper mesh rendering system for now. We'll just do some simple debug shapes and we can start prototyping as soon as. Obviously, I need to make the engine get into a good place where I can actually write some game code. That makes it easy and awesome to write game code. Because we don't want to just be find it very difficult to prototype. So there'll be a few small changes like hot code reload and make sure we can simply send stuff out to the renderer, right? But it's not too many things. So today we're just simply wrapping up on the material work such that the materials don't get in the way of prototyping. So we'll have material layers and we'll just simply finish this system off and not make it such that it's left in a mess so future Henry comes along and it's like, what's going on with this? So we're going to sort that today. And then we're going to hopefully move on to something engine related next stream, maybe tomorrow. We'll see. If any questions, feel free to ask away. Start with a quick prayer. Father in heaven, thank you, Lord, for this day. Thank you for blessing us with another day to do your will. Thank you, Lord, for giving me the idea for the game that we want to make and leading me down this path. I thank you, Lord God. I pray for a good stream today, successful stream, just to get the things we want ticked off today. I pray that ultimately all this stuff we do, gets it's not a waste of time, but leads to the right answers and experiences to learn from as well. I pray, Lord, that my viewers have a good time as well today and learn some things. And also pray that all my viewers who come by, Lord, that you bless them with the understanding that you are Lord and you are their Savior before it's too late, before their time runs out. Also pray that if anyone's struggling with anything in their family, I pray, Lord, that you attend to it quickly and swiftly and show that the Lord is there, caring and looking after them even when they don't expect. Thank you, Lord. In Jesus' name we pray. Amen. Cool. Right. So materials. What can we do? So essentially, we go to VK Shared, I think. There's some kind of thing called a material kind. Well, we just get rid of that, basically. There's not different kinds of materials anymore. There's just materials. So we're going to have a default material, which is going to be a raw material, or we could just call it a solid material, right? It's just a solid color. And we'll have a soil. Yeah. And that'll be it. We're not going to have a geometry material though. It's just going to be called a proto material, as in a prototype material. So that's basically a piece of shader code and a specification for what the parameters are. So they're basically property definitions of what to pass into the shader. And so material is basically a reference to a proto material with the arguments for the material. So you can have programmable materials that change at runtime, which is kind of cool. Nice. So let's look around for any kind of like geometry material thing, or what was it? Uh, okay, so graphics VK material layer index. We just get rid of that as well. There is now no longer no, we need this, sorry. Yeah, we're gonna have like 4 layers. Const expression, this thing 4. Yeah. 4 layers of material. So we'll say this GPU material. We shall have no detail material thing, we'll get rid of that. No detail material grid, that gets rid of. We'll have 4 material layers for the whole instance. So eventually to do move these to being per triangle face. Right, we'll do that when we have a proper mesh system. Yeah. So it's just some, grass blade stuff, and we did some grass testing and stuff, which we will come back to doing properly, but just get the game prototype done first. So material grid GPU, we get rid of that detail grid thing. It's now no longer a thing, which is cool. Less code, less complication, less, yeah, less complication. We're all good, all up for that. So cool, let's look for this detail material. So here's the material cache. Again, this heavily gets simplified now since the changes that we've just discussed. Get rid of this detail grid stuff. I know we spent like a stream doing it, but it was good to explore this idea to see whether or not it was worth it, and it wasn't. So now we know. We've now come out the other side with knowledge, understanding. So all this goes away. There's now no longer different types of materials. Just one type of material. Pro material, I mean. Okay, so geometry, let's get rid of that. All right, so material cache init, frame init, upload, allocate. Cool. No kind function, no detail, material grid. Lovely. Right, so let's go to the CPU side. Hang on a minute, is there anything else to sort out? No. Right, is there anything in the globals? No, nothing in there, I don't think. Cool. Right, so let's go to the VK, to the source code for the graphics stuff. So, CPU side. So we're just trying to find the material cache. Oh, it's right here, isn't it? Cool. So we want this, but we just want. Well, that's a good point. We need to delete all of this stuff. Delete those files. Graphic. Oh, not that one. Pro materials. Right. So I want soil. I used to have one called raw. But that's another one we're going to be doing. We'll delete these 2 things. Solid. So it's a solid color basically. So in the solid, oh, what's this? BB, whatever, we'll just leave that. So when we go to the materials, there's a sampled material. We had this before, but we've just got to bring it back. So diffuse, that will be a RGB. Yeah, I think E32 basically. And then emissive strength, float, gloss, AO. Now we could probably pack these down quite a bit. Ten. Yeah, I thought this could be like an 11-11-10. Or a 10-10-10-2, whatever you want to call it. Emissive color, same thing. And then a strength. Gloss. Yeah, maybe you can say 16, 0. I don't know, 256, is that too much? Probably not. Then 8, 0 to 1. Same thing. Do you even need it AO at this point? I don't know. The AO seems pointless to do. Cool. Right, that's nice. So let's go to the build system. If we change those. So soil, solid. Nice. Now let's go back to the, so it should be a graphics.c. Soil and solid generated. Yep. Then we just need to do the header files in the Vulkan side of things. We need the grass blade one. Let's get that one back, shall we? Oh crap. How do I redo? I press keys on my keyboard, but it's not doing it. Well, I lost that one then, didn't I? Right. Now I can't undo and get my stuff back. We should have just used Git. Right, so where is it? I want the Git restore code, modules, graphics, proto material. Grassblade. Right, then I also want to go back to the other file we had. How to view the open buffers. There you go, that one. Right, let's resave that. Cool. And let's get the Grassblade out. Right, so let's go back to the build main Grassblade. I nearly forgot about that one. Cool, so in graphics, VK shared, there should be this enum. I wonder whether or not... Oh yeah, we definitely want the enum. Cool, so they're the 3 different materials that we'll just keep around. Then graphics VK. So sort this out. Nice. So we got rid of different kinds of materials. Now it's just one kind, and it's just a proto material. Obviously, there's not going to be brick anymore. There's going to be soil, solid, and Grassblade. Okay, so solid. None is detail material stuff. What's interesting? Go to the header file. Okay, so we want and solid. Right, so we get rid of this function here. Yeah, so after we sort out this CPU side with the GPU side and clear all that code out, and then we should be able to do the layering. Well, we can test out layers. We'll probably just do that soil material and then a solid one on top and test that out working, which would be cool. I'm hoping we get that done today. Right, so we should be able to just delete a lot of this stuff, which is nice. Nice. What's going on here? So we've got a... None of this kind stuff. Also kind index. Oh, I didn't do that anymore. So we get rid of that entirely. That's cool. All this goes. All of this goes as well. It's just beautiful. Going back to the simple solution. Look at that. So upload code disappears as well. Bye-bye. Now, the kind disappears too. Or takes in a pro-material kind. That is wrong. Alright, this is just for debug assertions, so we just fish one out. So we don't have different kinds of materials anymore. It's beautiful. It's amazing. Yep, that's fine. Okay, so... Right, where do we get the index from? That is a valid question. From the name. How did we get that before? Bum bum bum. Right, I think we need the hash table back. The problem is I made the hash table do two things instead of one. So this is kind. It needs to now become a kind. Or an index. Index from material, pro-material name. So I can call it a... Yeah, something like that. That'll be fine. We just undo, we can find the code. So it was this basically, right? That's fine, no big deal. Right, when we initialize, we go over all the pro-materials, we work out this number of words, so U32s that go for that one given that index. Then we throw in the hash table a way to get to the index from the name, basically. Like that. But I just want to double check. We need the initialization code too. Yeah, that one. All right, lovely. So, nearly there. Super close. The next thing is... Right, getting the proton material index. There's a way to do that. Did I make that into a function or something, didn't I? Oh, it's here, isn't it? Yeah, so... Cool, we need to take that. And... Right. Deleted a function I shouldn't have, but that's fine. So it'd be called part material index, and you get that from a name hash. I'm not sure if this is the way we want to go, but it's just the way it worked before, so I'm just restoring it, and it's fine. So it just gets from hash table, basically, just makes it easier to use. Right, so we allocate a new material. Nice. Now, if this pro-material index is equal to E32 max, then we had a problem. We probably need to return some kind of error code at this point. But again, that's not really an issue for now. For now, this will do. Nice. Nearly there. So this grid thing, we get rid of all this code. Goodbye. No longer a feature, which is great. And voila. So I think this is all the CPU side stuff done now. The next thing to do is move over to the GPU. So we go to graphics materials. It's just included inside all the places that do material sampling. It has all the procedural materials in here, basically. It's just shader code. That's what it is. We've got some buffers, or a buffer soon. It's basically just a buffer which stores all of the arguments that get passed in for a specific material. You might, such as, you know, the solid material, its arguments, or the soil material, their arguments, just in one big buffer we stub allocate from it and have indices into that buffer. These ones don't exist anymore. We probably won't do SDFs anymore, so we should probably get rid of those, but we'll leave them there just in case. I don't think they'll be needed, but we'll leave them there. It might be handy. So got the PBR shading stuff, obviously. Yeah, we'll keep a lot of this code around. We've got the, the noise stuff, which we're going to be using more often. We'll do materials now. Just use those basically as the plan. So the brick material as we did it is not going to exist anymore. It's a cool idea, but we're going to do a material for a single brick later on when we need it. But for now, we'll get rid of this one. We're not doing sign distance fields and stuff. Not really a good idea. We want to do material layers, not really a good idea. It was a good thing to explore. So we'll just call it, obviously, material grass blade. So I think the way we're going to do it is just do it all in one go, I think. So none of this stuff. Yeah, I'm not sure. All right, let's just leave it. Okay, so we'll call it something like graphics material grass blade. Ta-da! Shade grass blade. Okay, and it's going to take in the shading structure UV. Well, the UV will come in anyway in the shading strut, I think. Maybe. Yeah, maybe we don't have to care about that. And this redirection stuff. Just a word start index. What about some parameters that come out? A normal and a scale. No, I'm not interested in that. But instead, we're just going to pass out the sample material. Now, so that means these will just get merged. So curviness comes in. This is the normal. So it might be cool. So if you're providing yet a normal. Yeah, is the sample material gonna have a normal on it then? A normal material space. Yeah, I think that'd be it. That's cool. So yeah, so this will come down here. S normal material space like that. Lovely. So there's sort of like shading UV dot X is in this range, is in that range. From the grass. What was it? Grass. Not part of grass emit, is it? It's from grass. Render layer buffer, I think. Oh no, it comes from the scene shade and all that, isn't it? For grass blades specifically, shading UV is this and that. Okay, so vein, like a vein in the middle, gloss. Get the color based on the vein, how close to the vein it is. Color out a non-metal. Nice. Right, so soil. This one we did the other day. So we get to heavily simplify this, which is great, just have one function. Again, we'll just move it up. Actually, we'll move this one down, it'll be easier. All right, so soil. We're doing this sort of clump thing. You know, a lot of it's test code, but we can. So graphics, material, soil, clump height. Just leave that. So it's just the overall height, yeah. Cool. Soil normal. Okay, so this function needs to get changed now to basically just shade soil. Now, just shading UV. It's a bit strange, all this. Right, it needs an offset, that's fine. Mm-hmm. Right, so normal material space as it comes in. That's interesting. Right. And then modify it basically. Right, so we'll keep that. Right, so here's the shade, the old shade. So we just merged them together now, those two stages, which is cool. So some kind of moistness basically, clumpiness. So there we go. So that shade. I was not using the right. Hang on a minute. And I wonder why that was programmed a bit wrong. Right, so I wasn't using h.y. That's why it wasn't coloring properly in some ways. Okay. Whoops. Glad we found that. So CH have been the clump height, basically. The clumps. So when we did the shading for those, it was a bit wrong. So h.y. Cool, so it does some coloring, some moisture thing, and yeah, voila, let's just leave it there. Cool, so I'm glad that's done as well now. The moss we're getting rid of, we're not doing this detail material thing. It was a cool thing. We might come back and do a sort of another moss one. But we kind of know what to do already. Wait, where's the distance to moss? Yeah, we'll just redo it again. It's not the end of the world. We know. Or we can just dig it up in the code base. But it won't be side distance field based though. Right, so what is this? This is shading. Right, yeah, we're getting rid of all this code. So this was the detail material stuff, where because it was ray marching, we needed ways to add volumes of extra detail on, but that was complicated of an idea. It didn't really work out. So we talked about that earlier, and I posted it on the Discord as well. We're just doing the simple thing now, because this route, which seemed right, doing ray marching, didn't. It added too much complication, and it was didn't really solve. It created more problems than solving. So we're just going with noise-based 3D textures now that are all still generated at runtime. So this is called ray march. There is no ray marching anymore. Right, let me switch some lights on. There's no ray marching anymore. So I wonder if we can just delete all this code. That'd be great. So yeah, we have these like layers and stuff, which is have 4 layers now. We'll do some blending in that, but yeah, this is all the detail material stuff. It's quite big, and it was cool though. Cool idea, but it didn't work out. Then this just changes the normal. Right, we've got to remember that code basically. That's the piece of code we need to remember. And we'll debug draw in it as well. Okay, so shade is basically all we want. Yeah, so we just pinch this and we just plop it in here somewhere. and we work out the rest. All right, so we just highlight all this code and we just send it off to the void. Bye bye. Cool, I like that. Now, let's go to the shade for a minute. Graphics shade. Oh, sorry, scene shade. That's the one. So material layers. So these are going to be per triangle. Now, all we need to do is simply go over all of them. They're stored in the instance. Yeah. So those get unrolled. Just a nice mem copy, yeah, basically, yeah. So that's for the mesh kind. There will be a separate grass blade kind as a triangle kind in the visibility buffer because it's slightly different. It's cool though. Yeah, a lot of the mesh stuff is still test code because we haven't got a proper mesh system yet. We're still going to be parking that a bit later now because got a plan now to do some game prototyping instead, which will be super cool. Posted about that on the Discord if people are interested in seeing. But I haven't discussed the game idea yet. That's coming very soon. So we're going to be wrapping up on material work, then getting ready for prototyping, basically preparing the engine for prototyping game ideas, which would be nice. So there's only one material. Right. So basically you clear it all out with this. Right, and then you simply just set the 0 one, yeah. And that should just, yeah, that should be optimized properly. There you go. So I'm glad we sorted that out. So back to the graphics materials header, which is included everywhere. So it just has the shade function. The basic idea is you want to go over all the layers and blend them. And that's a good point. We do need also some alpha blendings kind of stuff. So this is where the fun begins. So what we actually need as well is 4 values. So we could just do a U32, right, 8 bits each. I could manually do this, but then it won't be. So I could do the bit packing stuff like this, and it to give me 4 individual fills, but then I won't be able to use shifting ops the other. Oh no, we'll be able to. But yeah, we'll just do it like this. We'll just do it manually. So material layer alpha values. Alpha. Right, so essentially 4 times 8, or 8 times 4, 8 bits times 4. Unorm. What can I say? Unorm times 4. All add up to 1, and if they don't, right, then is that right? All add up to 1. Yeah, so all are going to add up to yeah, add up to 1. I think. Which means technically we don't even need a final layer. Is that right? technically you can get better precision and you can do unorm times 3, and then you do your first one, your second one. So you could do 10 bits each. Just do 10, 10, 10. And you could store maybe the number of layers in the final 2 bits. So that would be... And then... So on each triangle face, you would need to store 4 32-bit integers plus a 5th one. Right, just for material stuff. Yeah, I wonder if you could pack that down in some way. No, probably not. Maybe. You might be able to. So you see these graphics, VK. You could probably store 8 pro-material indices next to each other. Sorry, 4 of these next to each other. That makes a single U32. Then squish this down to 16 bits. That's 65,000 words of arguments. Then you could probably do some special roundup logic where you know that your prop words needs to be aligned to the nearest aligned to the nearest 4 or something like that, or 8, right? And so you'll get a bit of wastage, but then you'll get a bit of spacing between your material property words, maybe. But you can drop out the low bits, and then that would give you... Yeah. So then you could pack these better and still have, like, for instance, say if you had... Get a calculator so it's easier to understand. So a trick you can do. So 65536. Right, that's obviously 16 bits of information. Well, it is on the 17th bit, right? So what you can do is you can make it support. So in 16 bits, you can store, let's say if we aligned it to 4, it's an index aligned to 4. That can then support up to 1 million different property words. But you just have to maybe waste up to 3 different property words per material allocation. So you're essentially having... So you'll never have an index which starts at 1, 2, 3. Sorry. I should write it by 4, so that'll be 16. Yes, that'll waste 16, wouldn't it? Right, it's a bit too... 655, 3, 6. Yeah, so shift to left by 2. We'll get you 256. Wait, what's that? What is that number? Yeah, sorry, 256k. Cool. Yeah, so if you had... So what you'll do then is say if you allocated a range of words, and this stores just a bunch of properties. Let's say the soil. Sorry, not soil. Let's go to the solid. This is the solid material. It's just like a solid color material. So it's got one word for diffuse, another word for specular, another word for this one, and another word here for emissive strength, gloss, and unused, right? So there's 4 U32 words. So we can say every time we allocate all the words for these different materials that we hold an index to, we say we have to round that index up to the nearest 4. That means the 2 low bits are not going to be used, meaning we can store it in 16, we can store an 18-bit number into 16 bits by just shifting it right by 2, because the bottom 2 bits are always going to be 0. So that's how we can get some extra packing stuff. So if we can manage to squish it down to 16 bits each, we could fit 4 of those into 2 U32 words. So this could, we could really pack this stuff down. But this is not a thing for us to solve today. To do, perhaps we can pack this down even further. Now I'll put it here. Perhaps we can also pack this down even further by limiting by inlining SOA style, I guess. Yeah. So packing all of this together into a single U32 and packing all into 2 U32s with 16 bits each, right? And then aligned to 4. For instance, that allows for 256 each. Index being aligned to 4 words. So we can actually pack an 18-bit property word index into 60 bits by shifting right by 2. Something like that. So that could be fun. So that supports up to 256,000 property words, and I think that should be plenty. Like on it, say if you had 256k property words. Say if you had on average, I don't know, 16 property words per material, that's still 16,000 different materials loaded in a scene at once. So that's quite powerful. And then we can just increase the alignment if we need to change that number, right? That would waste more RAM. But then, yeah, that would potentially waste more RAM. But it then means that we can more tightly pack these mesh instances, which might be more important. Or maybe the material ones are more important. But yeah, this depends how important it is to have materials in cache lines. How this is dependent on how important it is to have materials closer together compared to mesh instances. You know, possibly, you know, this depends how important it is to have material properties close together. Mesh instances, you know, fitting them more into cache. Right, fit them more into cache, cool. Right, so anyways, so we've packed those into like a 10, 10, 10. Right, the final layer is inferred, right, as all layers add up to 1. Bingo. We can store the material count in the final 2 bits as well. I don't know. Should we yes, the first 2 bits are just the material count, something like that. Okay, so nice, we'll just manually do that. Now, what's next? Cool, so I'm glad we made that change and figured that out. It's been a good thing to understand this a bit more. So, the alphas are there. So when we do shading, it's changed, right? We want these alphas and things to be passed into that shading structure. Where's that? Okay, there's your material layers. Here's your alphas. Okay, scene shade. So we just want So for the grass blade, that would just be 1, right? Because the count goes in the low bits and it's just inferred. So the final one is just inferred. So 1 being the final one means it's inferred to be 1. So let's work out that logic. So what you have is what's known as the remaining alpha. So it's just 1. Now we do a for loop. Over 0 to the number of material layers. How do we get that? So that'll be, maybe that should be called capacity rather than the, hang on a minute, that's in the wrong place, but yeah, whatever, we'll just call it count. It's kind of a capacity though. Okay, so Right, what's not a generated file? This is the... Let's come back to this one in a second. Database file, we'll change that in a bit anyway. Right, nearly there. Cool, so back to graphics material. Now, cool. Okay, so we'll get the count. That's just in shading dot material layer alphas and 3. Sorry, the first 2 bits, yeah? That's obviously a 0 to 3 value. Hang on a minute. I did a thing which was wrong. Right, symbolizing 1. 1, take 1. But yeah, 0. So symbolizing. So rather than writing a comment, which sucks because comments suck, you could just write material layers count, put the actual count in, and do the encoding of that, and voila, self-document encode. Hey there, Don, how's it going? Welcome, sir, good to see you. Hey there, iSense. Hey, welcome, iSense you in the chat. How are you doing? Welcome to the stream, guys. Hope you're having a good day. We're just wrapping up some code, material code. So we grab the material layer. We grab the good, thanks for asking. Nice. I'm not doing bad. Doing fair stuff. Yeah, not doing alright. You know, I was super tired this morning. Yeah, long day at work. Had to try and find some issue which was like a race condition. Found it in the end. But yeah, that was long. But yeah, I was super tired, but I had 2 cups of tea, some green tea, and I'm more awake. Had dinner, put a nice bit of salt on the dinner. I was like, good to go. So, yeah, not doing bad. Yeah, I'm feeling a bit better. The weekend for me now, I don't work Fridays, which is cool. So I got to do some business stuff tomorrow, and then I'll be streaming in the afternoon as well, which would be nice. Not got any evangelism this week though. What else? But yeah, also been writing down this idea for this game and stuff on my phone. You know, been yeah, I've got a nice little notes on this game idea. It's going to be pretty sweet, I reckon. So I'm just putting that together. And I think I'll get a video together and I'll go through it in detail. Probably when I get back from my holiday. I'll get started on it, which would be pretty sweet. Be prototyping on some game, which would be nice. Is it based on previous engine you're developing, or is this one from scratch? It's not from absolute scratch. I took some of the code. It's got a different renderer. The OS layer stuff is basically the same. The GPU layer is now focused towards being a Vulkan specific layer rather than a general GPU thing, because general code kind of sucks. The solution, the problem with this solution though, is whenever we want to port to another platform, we'll have to write another abstraction over whatever the graphics API is for that platform, and then GPU means like my own graphics API on top of Vulkan, right? Just making Vulkan easier to use, right? For what I want it to be used for. Specifically for Vulkan and its feature set, basically. And then the graphics layer, so for the game or engine, what I'm going to call it, right? That is specifically for Vulkan as well. So that means that's a lot of code that's got to be written when it gets ported to another platform. But the pros is that you can do platform specific code and you don't have to try and find some magical abstraction which fits absolutely everything, which nothing ever does. And then it means what you can do is simply throw out one renderer. You can keep that old renderer going and just build a complete new one without having to worry about fitting some old abstraction somewhere. But obviously the downside is you've got to write all the shader code again and everything, right? So that's the con. It's quite a big con, but that's the thing I went with in the end. What kind of engine games split for your time? It's more a case of enough to demo engine for patrons or shift into game focus. That's a good question. So, all right, let's double check again. So, what kind of your time is more a case of demo engine for patrons or shift into game focus? Yeah, so I think in like the engine will be built. So I'm thinking the game is going to live inside the engine repo, right? It's not going to be something separate. Although I think and this is what we've got to figure out, right? Is like there's going to be an engine API and there's going to be a game. I think I want to try and yeah, we need to find how do we split that off, I think. Into a separate sort of folder or something like that within the engine though, I think. So that means if there needs to be another executable, you just make another folder and voila. But I think for now the engine is just going to be compiled into the game. And but for my time, that's your second question. That's your main question, isn't it? So effectively, I'll switch into doing the game prototype and getting that to a reasonable place where it's like we know what the game is. And then it will come back to doing like mesh rendering, lighting, right? Make game look good. Right. So first it'd be like make game fun. Is game fun? You know, when we find game is fun, you know, maybe I'll add some other things like networking or something like that. I don't know yet. So I'm thinking about maybe doing a networked game because I like the idea of being able to play with a friend that's next to you on the couch or over the internet. So we'll probably make sure all this sort of stuff works out with the gameplay and then come back to rendering and just make it look really good. But yeah, find what the game is whilst also building it into an engine at the same time, like a common set of just a more lightweight engine and stuff to use for prototyping any more games in the future, basically. If that answers your question. It will be split between the game and the engine, right? Because when you work on the game, and I need to get something in like networking, well, we'll need to go and add that into the engine, however we're going to do that, right? So there is going to be platformy stuff which will get done. But we're going to try and focus mainly on the game first. Right, so go over these alphas, these layers, you grab the material, you separate this stuff out. Get the product material, which is basically what Shady you want to run. And it's a solid soil okay, that was right. And voila. So you do your shading, you get what's known as a sampled material. That's where the fun begins. It's just a weighted blend. So here's what we do, eh? We have the final material. Man, naming stuff sucks. Call it shaded. So this seems to be zero initialized. Unfortunately, zero initializing in GLSL isn't really a thing. Yeah, you can't just do some specific initializers, I don't think. Zero initialize in GLSL. Is that a thing? Ask the AI because, you know, Google's were in the search engine. A strut. Yeah, you just gotta type out manually. No big deal, right? You cannot do that, which zeros everything. Still need to provide a field for each. You know, I guess that's kind of okay because that'd be a compile error, right? It's probably better than this one. Right, it's probably better that you just... You know, it sucks, but here we go. It works. This way, if the structure changes, we can simply just... Oh, it will do it be a compile error. So there we go. So zero initialize it. Then you have like an overall... Well, we won't need an overall weight because all the alphas add up to 1, right? So here we go. So we get a material. Let's just call it S. So in the macro, it's calling the function returns S, right? Now, we probably want to turn it into world space. Is that true? Yeah, we do. Alright, so that happened down here. Hang on a minute. Sort that out. So we're simply going to take all of this Now we need some kind of alpha. What is the alpha? Well, if the index is equal to +1 is equal to material layers count, which it most likely isn't. Well, I don't know, it could be. So let's do greater than or equal. So if it's greater than or equal, then we just use the remaining. Else we use material alphas shift right 10 times index. Okay. And then we AND it with 10 bits, so it's 3 FF, yeah? Cool. And then that obviously needs to be like multiplied by 2. Sorry. It's 10 bits, isn't it? So divide by 1024. Okay. Then remaining alpha needs to be reduced by alpha. Okay. So, sorry, 123, right? Because 123 would be, that'll put, that manage you to actually get proper 1.0, wouldn't it? So yeah, it will be undefined behavior if it adds up above 1, basically. Well, by undefined, it means I didn't think it through. Which is how undefined always works, right? 743. So shaded dot this is equal to the thing we've sampled multiplied by the alpha, and it's accumulated. Right, so it's just a weighted blend. I think that'll be fine. And since they all add up to 1, then no problem, right? I've saved on some maths functions now by not having to divide it, right? Since all the alphas add up to 1. Bit of a premature optimization, but there we go. Cool, so that would be super awesome. The next thing would be, yeah, so this won't be unrolled, which would be cool because this comes from a variable, which is awesome. Because if we unroll it, our code would just multiply like crazy because these functions are huge, right? Well, they're big. They've got tons of FBMs and all this. Right, so when we calculate surface color, passing this massive shading structure, and we don't do ray tracing anymore, sorry, or remarching anymore, it's gone. We do shading. And it can be possible to have stuff discarded. Now, how do we know if we want to discard? Is that something we do anymore? Because we've just got alpha. Well, that's how much they blend between the layers. But you could also have some degree of transparency on an object, maybe. I don't know. Do you want that to come from the material or the overall mesh? I think you just alpha on the whole mesh. You want to do per pixel, like, transparency, do you? I don't think we want to do that. But we could add that in the future, right? But if we don't need it, let's not worry about it. So, right, this discard isn't used anymore, so we'll get rid of that, okay? Simple. Now, cool. So just the the classic PBR, shader, shading stuff, right? calculates all the radiance and stuff like that. Okay, so very nice. Right, let's just go to scene shade. Double check there for a minute. Hey there, Fast FGC. In February you came back. I've been Christian for probably, well, lukewarm Christian. Sort of believing, but not really fully believing, for around 4 years, I think. And then last year, I really got serious about it last year. I had my own encounter with God, and He's given me things to do, and you know, yes, now my life, the verse Matthew 6, verse 33, but first seek the kingdom of God and His righteousness, and all these things should be added onto you. I had I realized God was real, and I first believed in, oh, I gotta, I'm such a bad person. I gotta do all these works now to prove, I'm worthy of salvation or whatever. Not really understanding the gospel properly. But I was doing works, a lot of works for like 2 months, trying to be a better person, trying to do things for God. Read my Bible all the time and learn and try and get people saved. But then I realized that I'm still a bad person. how do I possibly deserve heaven? Then I realized the gospel. I answered the gospel completely wrong. Yeah, it's not what I do. It's what Jesus has already done. Paid in full. Paid in full on the cross. It's by His grace alone that I'm saved, not by my works. And it's amazing. It's not to say I don't do anything for the Lord now. It's just changed. I think when I first realized this, it took I all of a sudden lost my zeal that I was because it was driven by fear of underachieving and not making it to heaven. But when you realize no man can possibly make it to heaven by his works, because man has to be perfect, and you put your faith in Jesus' work, then no longer is there the fear that you're not going to make it to heaven. Now instead it's mainly the good works is replaced with love, isn't it? So you do good works out of love for God and His creation. And so it took me, what was it, maybe a couple more months of learning and understanding that, hang on a minute, it's purely by the grace of God that I make it to heaven. It's a gift, not of works. Can't boast about it. And then it becomes more of like, hang on a minute, this is like the only thing that's getting in the way from you getting to heaven is putting your pride away to say, putting your pride away that I've got myself to heaven. It's not that, right? It's humbling yourself before God and accepting what God has done to get you to heaven. And yeah, I think I've become born again from around that sort of time. It's really incredible, really. Yeah, God's given me a mission. He's told me is coming soon. He's told me that not everyone's going to be saved. There's not that much time left. And he's also told me that I need to go out and evangelize. And I don't know if you know about me, but if you follow this channel for a long time, I've probably not the most I don't I guess it's cool these days to say someone's got anxiety, right? But, I had lots of social anxiety for a long time. I don't know if you know, but 10 years ago, I used to stutter. I used to not be able to speak properly, fear, standing up in front of people. But I can tell you, since, so how can someone like me go out and preach the gospel to people, out on a microphone? But literally, God has just helped me get completely over that fear, and I can just go out there and preach about Jesus and how great Jesus is, and yeah, how much it's changed my life, and how much more of a better person I am now. And yeah, there's no fear anymore of any of that. Yeah, it's incredible, really. And yeah, that's the power of God, basically. Yeah, it just takes away all fear, and no longer fear anything. Yeah, I think there will be moments, right, where might get a bit of worry, but then I realize, like, go back and realize, like, who I am in Christ, basically. But I pray and hope that the Lord doesn't test me about my fears. But you know what I mean. Test me with crazy things. But yeah. I'm not a Christian, but I've recently started getting into biblical texts. Cool, going through Old and New Testament. Nice. For literary reasons, and I think their text is very interesting for historical and literary reasons. Cool. I'm glad you've picked it up. That's great. Yeah, I find that, like, there's a Bible verse. There's Hebrews 4:22, right? For the word of God is sharper than any two-edged sword, piercing even the division between soul and spirit, of bone and marrow, and is the discerner of thoughts and intents of hearts. So what that basically means is, when you read it, especially when you read the Gospels like Matthew 5, in 6 and 7, Jesus' Sermon on the Mount, you realize how it's the discerner of thoughts and the intents of your hearts, right? Like, you realize how much you fall short, how much you're not a good person, and without it, you really fool yourselves into saying, "Oh, I'm a good man, right? I'm a good husband. I'm a good, whatever, right?" But really, you lie, you steal, right? You might even have murdered in your life, but you've been making excuses about it. You might have even, and Jesus said, right, if you get angry at someone without any good reason, right? A bad mood isn't a good reason. You've already committed murder in your heart. Right? That's the standard God has, which is perfection. So when you really read these things, it really does reveal sin, and that's what the Ten Commandments are all about as well, is revealing sin. But yeah, it's great you're reading it for history reasons. People find, they want to come up with problems about the Bible, but one thing is they keep digging up stuff, and it just further confirms the Bible over and over again. I think they've even found, like, where, that city called Sodom got destroyed. Well, they've found, like, probably where that is, and it's basically lots of, like, does the Bible describe it as being sulfur, like crystallized or something like that? I forget the specifics. But if you look it up, I think that they've found probably where it is. So it's interesting how historically accurate a lot of that stuff is. That's awesome. Okay, so where was we at? Yeah, I think this is alright, isn't it? We're just going over the scene. Oh, sorry, it's graphics. vk.c, yeah? So this was it. So what I want to try and do is get this thing up and running again and simply have 2 layers of, so layer 0, a layer 1, and that would be we want a soil material and a solid material, and I think we'll just make it like purple or something like that. I think that's the idea. So we'll do a solid, and then I think we can just do some alphas as well. Basically material layer alphas. And we'll, these have to add up to 1 kind of thing. We don't really have to add up to 1. We can just say, like, we only really need to pass in a 0. That's right. So we'll just pass in, hey, this takes 0.5. And we'll code that 0.5 in the thing properly. So what we're looking at, so let's change the material cache. So again, material layers is going to be per triangle, but that comes later, right? We're just doing it per instance for now. So material layer alphas. And then we'll finally pass in the material layers count. Okay, so we'll just take that over to the right thing. The idea of the flood myth might refer to rising sea levels 10 years ago, many cultures have it. Yeah, or it could be the fact it was true. Because they've even probably found Noah's Ark as well. I think there's some recent, it's in like Turkey. They found it ages ago, and even the FBI found it in the 50s, but they kept it secret in some secret documents. But there's literally where Noah's Ark is, and I think there's some debate where people are saying it's not true. I think like what's his name? Wes Huff is probably saying it's not true, but I think it's true because there's some evidence around it, but I don't know. Well, I was talking about the specific place where they found the Ark. But I think Noah's Ark is true because obviously I believe the Bible, but it's a myth that's, as you're saying, throughout many cultures. And the reason why it exists in many cultures is because of the Tower of Babel, right? After Noah's flood comes Tower of Babel. You get Nimrod, who tries, he creates a one world government, basically one world city, and they try and build the tower to heaven, whatever that means. There's many theories on what that means exactly, but God sees that they're advancing in their technology, that they're trying to achieve heaven to become like God with one language, so he confuses their language. So if you look around today, we're probably trying to build a similar sort of Tower of Babel in a sense, where we're trying to have a one world language, one world government, and God will probably look down at us and be like, probably be like what went on at Tower of Babel, but something different, like tribulation, like Antichrist coming onto the scenes. I wonder if are you familiar with the game I'm Jesus Christ on Steam? I was wondering what you think about games like that. Is it similar to what you want to develop? So I think I've briefly looked at the game. I've seen someone linked it the other day or the other month sometime. I think it's a little bit questionable to play as Jesus. Because like controlling God, right? You know what I mean? I think whenever you do that, and I don't know, it's a bit. I think you should be careful with that. Like it's kind of like there's a line, and I don't know where that. And I think it's like you're stepping on the line, or maybe going over it. I don't know with that one. Um, but it's, and actually experiencing being Jesus, right? The whole point of being a Christian is not so you can be Jesus, right? And it's more of like become like him, if you get what I mean. It's but I think it's great though that you know getting more of, I've not seen the game specifically, but I'm sure you play as Jesus throughout the Gospels, right? It's good that you're getting that story out, if you will. But just the whole sort of playing as Jesus is a bit questionable, basically, I would say. You've read one of Graham Hancock's books, right? Probably the best to think of it as fiction, right? You're talking about the Younger Dryas period stuff, but he presents the idea that the lost history, the Sphinx, the layout matches the stars 12,000 years ago, etc. Yeah. He softens ideas from that book a lot into a bunch of lost cities around coastlines. Sea rises, levels rise at the end of Ice Age, right? Fair play. So there's theories though about the Ice Age possibly well, there's theories about where the ice came from, and that came because of a global flood. You can look at those up. But yeah. Graham Hancock's, it's not really his idea anyway. It's the Younger Dryas period of thing. I think there is older civilizations and, with great technology. I think, I believe in quite, if you believe there's, Genesis 6, right? Genesis 6. I'm glad they got the King James there, but I can't thee thou though. Thee thou thy. It talks about these sons of God coming down and taking wives. Right, remember against to multiply on the face of the earth, daughters of men were born to them, that the sons of God saw the daughters of men that were beautiful and took wives for them. And God said they should only live 120 years because they're getting quite evil, basically. And the wickedness of man was great, that every intent of his heart was evil continually, and the Lord said that he grieved, basically, making man on earth, and he will destroy man and every creeping thing as well. So this is where the Noah's flood comes in. So the theories are from this stuff. I'm just trying to get my book. Look at the book. That the sons of God, angels, came down, mated with women, and they made hybrids, right? Giants. And because they're angels, they have heavenly knowledge. So they transfer the knowledge. And there's the ancient book of Enoch, right? And that basically describes Genesis 6 in more detail. It's not part of the biblical canon, but the Ethiopian lot had it, and also it's found in the Dead Sea Scrolls, portions of it. Not the Book of Parables, though. The Book of Parables is interesting, because if it's truly came before Jesus, that's incredible. But basically you find out that these angels gave humans technology, like how to metalsmith and, like make weapons of war and look at the sky for astronomy and stuff like this, and heavenly wisdom, which they shouldn't have had. And it's where demons come from, basically. So fallen angels are the angels which rebelled against God and did this. Demons are the giants, the hybrid giants, when they got killed in the flood, that they're disembodied spirits of these Nephilim, these giants. And they basically roam the earth, and they're demons, right? They don't have bodies, but they're spirits. And that's where demons come from. What else? Yeah, so basically, if there's anything that... Where does that come in more from this thing? Yeah, so basically, old civilizations with high technology probably comes from fallen angels, basically. So if you don't know Nikola Tesla, lots of these scientists and things, they always get these ideas which come to them, and that's what they would say, right? I got this these ideas just got given to me, right? They never really took credit for them, and they said they will hear these voices, whatever, which give them the ideas, and they'll do this sort of, they'll just kind of be a scientific, they'll have lots of intuition to build new technology. And so lots of this stuff is probably coming from those fallen angels seeding man with more knowledge man should not have, basically. No dinosaurs and Big Bang and so on. How do you reconcile science for your worldview? So, you know, science, like, okay, first of all, evolution is like theory of evolution, right? It's called a theory for a reason because it's a theory. The creationism, I fall on the Bible, which is basically points to creationism, right? And if you think about your body, right, you are a biomachine, right? You have DNA which can store petabytes of information. It's the most impressive storage mechanism on planet Earth. If you randomize things, can you get order from randomness? The answer is no. It requires some kind of intelligent mind to create order. We don't make computer programs and say, hey, let's just randomize the bits and just hope we find the best modification, right? Because we know statistically that does not work. So statistically speaking, when you have lots of instances of organisms having mutations, they're not really going to create new code which creates order. Oftentimes they'll create broken pieces of code, right? Imagine if we took a binary executable. We all know human DNA 4 gigabytes, I think. No, it's far more than that. You store petabytes, I think. You know, if you take a binary, right, start changing random bits in that binary, the more likely it's going to keep breaking more and more, right? If you did survival of the fittest on those binaries, right, how long until you get complete new functionality which actually works and is going to be good just because it's survived, I don't know, some kind of metric, one single metric surviving, whatever that means, in this computer program algorithm, analogy. It doesn't seem like it's a plausible thing, right? Just because something survived and had more babies, does that really account for absolutely everything that we see in life? It doesn't seem like it, right? But yeah, so what else? Anything else I want to add on that one? But yeah, what you find out in modern day science is that science is not the best ideas float to the top. It's more of like, wait until a generation dies out and then ideas change. Science is quite often silences people and will try and forcibly remove certain ideas from coming into the picture. And, you know, you just look at COVID to see that, right? You know, we've been through COVID, you know, that's the thing. But yeah, notes of history. But yeah, I believe that dinosaurs existed, right? I'm not sure where they came from though. Were they part of God's creation? Were they on the ark? Maybe. Were they part of this son of God, you know, son of God, I mean angel in Genesis 6, fallen angel coming down, breeding with man and maybe breeding with some DNA of animals and creating these horrible, monsters maybe. Just theory. Maybe. So here's the thing, dinosaurs, right? They say they're billions of years old, right? Dinosaur, it's in the Bible, right? But soft tissue, right? Scientists say soft tissue can only last up to 10,000 years. If dinosaurs are really billions of years old, what you've now have to do is to figure out how it was preserved for billions of years. And by the way, they keep saying, this dinosaur died out at 15 billion years, and this one died at 65 billion, or whatever it is. Sorry, the Earth is probably, they could say 65 billion, but you know what I mean? They just keep on adding billions because of their rock layer theory, which probably doesn't hold out. But these, I think, have been found near the surface as well and stuff like this. So they've got lots of questions to answer. And dinosaurs probably weren't 60, odd billion years ago, whatever the number is, right? Or okay, it's probably millions, right? But you got what I mean? They just keep doing some big odd number. 65 million, 120, 183 million. But yeah. So they've been found, they exist. That's the basic principle of genetic algorithms. I'm not sure what you mean by that, Lenny. Sorry, Davros. I've been trying to... I'll get to what you're saying. I'll read your thing now. So, standard... you accept the standard picture of evolution. I just thought of an idea of I just thought this idea of lots of episode in history and as a basis of a lot of myths is viable. Modern humans existed for 200,000 years. I think according to evolutionary theory, whereas recorded history is about 10,000 years. Lost, maybe. Mm, brain is 16 petabytes of connection weights for crazy. I was just curious if a lot of modern believers don't believe the literal stories of the Bible or think of them more as fables or whatnot. Yeah, the thing is that's a problem because that means God's word is not God's word, and then it's a problem. I prefer to check the book. But Gemini says a human chromosome contains approximately 3 billion base pairs. It translates to 715 megabytes or 15 gigs of data, depending on whether it's right. Okay, so that's just this equates to 2 bits per nucleotide. Fair enough. Gigabytes of data. But yeah, so if that is all used for something, I think scientists want to say that lots of DNA is like junk DNA, but the more they look into it, the more it's just like they couldn't know what it possibly did, so they just called it junk DNA. But you find out lots of that DNA is actually used under stressful conditions. So basically, you're built with a certain piece of code, like certain set of code, and if you are under lots of stress or in different climate conditions or whatever, different bits of DNA basically come on, right? So yeah, the whole junk DNA thing is just some thing to say, look, this is why evolution is true, not necessarily to scientifically prove or find a scientific answer, right? But anyway, it's something you can look into. I won't take my word for it. Take a look into it. On the note, do you use AI for coding? I use it for research and stuff I don't really know, or if I'm stuck on something, I'll just chuck it into AI and see if it can help me out. But I try and just program much by myself. I don't use it to like massage my code, and I don't let it touch my code base, put it that way. Alright, so how are we getting this stuff in here? So... Right, so I think we want to do a for range over index. Yeah, and another thing about evolution as well is they teach you at school and they say this is the best theory we got. And they will describe it and explain it. And they don't really give you any sort of like competing theories as well. And they basically just lead you into thinking this is fact, right? When it's still called a theory. And then everything gets based off of that, right? People's worldview and people's understanding of like just every other piece of science gets based off of this one theory, which is not proven about where humans come from. Right? So people describe their mental health or whatever as evolution, right? So that's another thing as well. But yeah, I think it's more plausible that human DNA is degrading. Like if you take the biblical view, right? Because if you take evolution and whack it into the Bible, right, then that means before Adam, the world was sinful, right? And then that means God did not make the world good, right? So it basically breaks God's word, and therefore God's word is not true, right? So this is why people don't believe in the Bible, because of that simple fact, right? Science disproves, Genesis 1:1 or whatever. So this is why being a Christian and believing in evolution is not necessarily the best thing. It doesn't logically make sense. You can't do both, I think. I thought what else other point I was going to make. Based on that, isn't all of it just a theory then, including religions? Yeah, but the fact is that you don't teach any other theory other than one theory, and then say that's the best you got. But yeah, this is where basically you have, proven fact is quite difficult. It is possible to prove something as fact, but at the end of the day, there always has to be a degree of faith, right? You have to have faith in where the facts come from. You have to have faith in them being obviously true and not being manipulated over time. You have to have faith in the fact that there just has to be some degree of faith, right? For instance, I think someone brought up to me, how do you know who wrote the Bible, right? He's like, I know Stephen King wrote Stephen King's books. And it's like, well, do you really? Because there's that theory which Stephen King has ghostwriters, right? Hence why he's able to write so many books. So there's always faith behind certain facts, right? Where you get them. But yeah, so and that's just because we live in this current world where we don't have where lies exist. Material layer alphas. So we want to cram in there. Which way would it be then? So you're getting them out low to high, so it's the other way around, isn't it? So you want to store 0 in there. So you would do a reverse index. Pour that on. And do a shift left 10 beforehand. When you get out there at the end, we do a shift left by 2, and then we OR on the final count, which has to be less than the capacity. Right. We need to take one off that, obviously. And you probably want to have one material. Oh, yeah. We're going to always want to have one material. We expect at least one, okay? That'd be quite dumb if you didn't have that. Right. So that is cool. That means we need to add one the other side. So that'd be graphics materials. We had that in the shade code. So it's cool. Right. Glad that's in there. So I think we can now just simply run the script. Just got to fix all these. Did we run the code gen right? We did, lovely. So, man, it's warm in this room. It's definitely getting summer. Let me open up that window, get some fresh air. Right, got some other problems here. Was that saying it's a float? That's wrong, isn't it? Hang on. Why are you telling me it's a float? That ain't right. Yeah. What are you complaining about? Oh yeah, this is a float. What a good error. So we want to times that by 1024. 3. Right? Neural nets versus human brain size, we still have some headway. I see estimates that match the human brain. You would need 100 trillion parameters. I have 16 petabyte number from somewhere as well. Brain versus genome size is relevant to nature versus nurture debate. I don't see a digital computer being. I don't believe a digital computer will be conscious. Right. Yeah. That's the thing, right? Yeah. You know, as a Christian, it's interesting territory too, because it's like, at what point could, at what point could AI just be hijacked by some spiritual entity, right? Is it possible? Right? I know, you know, it's just it's an interesting thing. Yeah. Maybe it can't, because it's not a human, right? And demons can't maybe interact with, but they can interact with objects, right? So yeah, maybe it's an interesting concept. But yeah, I think what's concerning though is humanity is going to go towards merging with machine, because man is going to feel, you know, it's classic man trying to become like God, basically. You know, trying to obtain the knowledge before man can handle it, right? You know, it's knowledge given by external forces, put it that way, and man shouldn't have it just yet. So yeah, it's going to be quite bad. I guess the question is, how long until you would put a chip in your brain where you got an AI buddy in there, and it's your pal, and it's telling you all the information you want just with a quick thought, and then you're now, you know, you now got like superhuman ability to think. You can record memories and have them played back, and, you know, theoretically live up to 300 years old or whatever it is. Like, this is just like the devil offering it a glorified body before God gives it to you. Because now we don't have this fully biblically mapped out, but probably you'll be able to communicate without talking. Quite possibly. Considering heaven's just higher technology. Well, not just, but is higher technology. Glorified body means you don't die. Means you cannot sin. So the unglorified body, which the devil's going to try and give to everyone, is going to be a copycat version of that. It will restrict you in some way. Place limitations on you. So you can't act in certain ways. interesting. What is that? Oh, I've already removed it. Yeah, so I wanted to add the soil. Oh, these guys. Right, so allocate. That double allocate. What's going on there? Did somebody copy paste code? Somebody, was it me? And yes. Man, this is gonna be cool. Right, so we get rid of all this crap. This detail grid thing, we don't do that anymore. And there'll be some upload code I have to be careful about. Man, we have material layers working after this stream. This would be cool. Right, one test instance. Sure. Material alphas and 2. Okay. So the second one you don't need though. So you would just say if index plus 1 less than. Right. Nice. Nearly there. So where's the upload code for that soil material? Let's find that and do a solid one. So this is the final place and we can start testing stuff out. There we go. So solid material, diffuse, vector 3. Sorry, not vector 3. Hang on a minute. So RGB 10A2, I think. Wait, did we even write that shader code out? We didn't. It's got to change. Got to write that shader code. Right, we'll do the parameters in the shader code, then we can run it. Where's the right thing? Yeah, this one in it. Most British function ever. So it goes up to 1024 on each channel. So we could say red, green, blue. So we did red. Yeah, we did 512 red, 0 green, 512 blue. That'd be like purple, wouldn't it? So we'll clearly see this color basically. It'd be horrible. We'll blend it in. Then, let's just make it super. No, okay, we'll leave it like that. We'll have no specular. See, alpha needs to be 2. Sorry, 3. Because there's 2 bits in there, right? The alpha. Then emissive color. Again, that. Then when you say V0 solid material, there needs to be some things here. What's going on here? Yeah, we need to like... Another thing we should do as part of getting the engine ready is making it such that we can recompile the code a bit quicker. Not doing a super perfect system, but just maybe doing another compilation unit somewhere for a few things. Maybe. Or maybe not. Like in the future, it'd be good to like make my header files super small and not include windows and all that, but that'll come later. When we actually, you know, tidy up the code base or something. But emissive strength set, just be 0, I guess. Oh, come on. What's the other one? Gloss. One gloss, please. And the other one is unused. Cool, so we can set that as solid and voila. Nice. So let's go to the... I forgot to add solid. Yep. So let's find soil. Let's grab this one. It's super easy, super quick. Here's the procedural material. It's just a plain color, right? Plain material. So solid. It's not complicated at all. So we've got to copy all the parameters and all that from the properties buffer. You got to get them the right way around, which is a bit crazy. So if you reorder stuff, it's going to break, but yeah, just the way it is. Diffuse specular emissive color bit for 0. Cool. So there we go. So this will then mean we can decode the gloss. V0 is solid. I don't know why it needs to be. Oh yeah, because we need versioning because we're going to save that to a file at some point. That's why that's there. And then emissive strength. So that'll just be so we go over all this, fill it in manually. S.diffuse equal M.diffuse. Hang on a minute, there's like an RGBA thing, so unpack RGBA 10.2. RGB A102. Yeah, that's the one. And then emissive color. No, sorry. Specular. Then the emissive is going to be emissive color multiplied by the emissive strength. And then normal is just going to be a vec3 pointing toward the camera in material space, if you will. Then actually it's probably not bad. Sorry, it's a bad idea. You want to pass in. There's a way to do it. Yeah. Move it from world space. Into into material space and pass that one out. Yeah, we can finalize all that stuff later on. Put some gloss in there. Then 1A, okay? Nice. So there's some solid. So I think that's it. Nearly there, apparently. Yeah, no syncing on those things anymore, that's true. Any more shader code that's not compiled? Right, so that's 586, I think it said. Right, it's complaining. So, right, this just needs to be an RGB. Hang on a minute. Yeah. Getting close. Why did Clang fight? Oh, okay, interesting. Right, we're missing grassblade and graphics.c, I think then. Yeah, stuff to make better. Like every time we make a new material, we have to change like 5 different places. Not the best. If we could put it in one, that'd be great. You know, like one header file that's included in many places. Maybe. I don't know. You know, we can reduce that a lot. That would be cool. But again, future problem for future Henry. When that becomes a problem, right? So 714. What's this complaining about? Right. So that's just the UV. Next. What are you complaining about? Does not return a value. Dun dun dun. Right. Return shaded. Next. Scene shade has still got some old thing in there, like that detail thing. Nice. Right, let's try that again. Nearly there. 155. It's complaining about... Right, I need to say dot bit filled 0. And here we go. Ta-da! Right, so here is the earth material, the soil material that we made in a previous stream. So you can change stuff like, well, that's the sun, that's the exposure, auto exposure bias, not that one. There's some debug properties. Well, that looks better, doesn't it? Yeah, these are like the clumpiness thing, parameters and stuff. But yeah, it's the clumpiness. There was another one. That was the wetness, I think it was. Yeah, it's not really that good. But anyways, stuff to make better. So the reason why we're here is because we're supposed to be seeing a bit of purple. I don't see no purple. Not very nice. We're supposed to be seeing a blended material. I don't think there is a blended material. So what we can do now is just debug it. So let's go to print. Yeah, I'm just printing from the shader. Right, so that's the soil height. We can get rid of that. Now, where we do that layering stuff, so it's like a layer. Yeah, the shade. So here's the layers, yeah? So what is the alpha? And what I want to do is also print out before. So if the mouse is at a specific coordinate, right, we'll print out a 0, 0 as a separator between frames, and you know, we should be seeing 2 layers, yeah? So of alpha. So what do we see? That did not compile for some strange reason. I don't know why it didn't compile. Do we have hot code reload working? I don't think the hot code reload is working. Right, there's a 0 alpha layer and a 1. Alright. I think I just got my Boolean logic the wrong way around. I think that's what's the problem is. So there's some Boolean logic somewhere. Right, if it's greater than or equal to... Oh, we should already print out the number of layers. Yeah, right, let me just... My hot code reload is busted. We need to kind of fix this. Sometimes it requires me to delete my build directory. Not a big deal to rebuild the engine at the moment, so there we go. Okay, so apparently there is two material layers. Right, so hot code reload is going to work now. So the first alpha value is 0. Right, why is that? Sounds dumb, I know. So it should have encoded 0.5. So is this really being punched into every place we expect it to be? The answer is yes, I think. Right, let's look at this. So alpha is equals 0. You got two material. Did I say one material layer? I think I did, didn't I? I did two. Right, we should. Anyway, we'll sort that in a sec. Right, so two material layers. First time you go over here, it's going to encode this and then take the one from the back. Let's grab 0 in it. Hang on a minute. Do we need to take 2? So, yeah. Take 2. I'll do it. No, I'll restore this file, damn it. Command prompt. You're not like Linux. Oh yeah. Material layers, boys and girls, look at that. Can you see it? We can also hook it up to a parameter. Alright. Hang on a minute. Gotcha. Alright, so let's hook up to a slider. So let's say you have to get the first one. Yeah, so you've got one alpha at 0.5 and the other one at the remainder of that, yeah? So, nice. Now, if we take this and say, actually, we get this from gdebug unorm 0. Is that hooked up to anything right now? No, it's not, okay. So we'll just do that. Now it's just this. To bring up the settings, we've got the debug sliders in here, because it's just easier. And here we go. So we're blending on that solid purple material. And if we go all the way to the right, it's solid purple. And we can sort of alpha blend between the two things, right? Ain't that cool? So I'm not sure if this is right though, but like, why is... Yeah, there's something about these parameters maybe. Taking the average might not be the right thing to do. I don't know. Yeah, maybe there's things to figure out, but we've got up to 4 different layers, right? And yeah, amazing. Amazing. Cool, so this puts us in a super good place. Very nice. Right, so I'll be throwing that up on the GitLab for the people supporting the channel. Thank you so much. Appreciate you all. You can support the channel and get access to the codes running your own local machine over here. And there's a Discord if you're going to come and hang out in the meantime. So before we go, I'd like to give you guys a brief... There is a... Let's go to the plans. Documentation. Right, let's talk about the game plan, if you will. Right. Now, I'm not spilling the beans exactly on what the game is just yet, but for those who don't know what we're doing next. I was going to be doing meshes next, but I was thinking, you know what, we've not really got an overall big direction, so we should probably have that first and drive the engine from the game rather than the other way around. Although we are going to be coming back and building the technology, but we first want to get the game prototyped out and being fun. So, hang on a minute. Hmm. Strange. Can't see the stream up at the moment. We're going on, is it? Can anyone tell me if the stream is still going? It's sort of a bit funny here. Seeing odd. When did that go? Going to YouTube though. Twitch is busted. Not playing back on my phone, put it that way. And the bit rate's coming up a bit weird. Super strange. Alright. Well, for people on the VOD, I guess, who are watching back, we're going to be preparing the engine for building game prototype basically tomorrow. We'll be starting that Friday, 2 p.m. GMT +1. So we want to like basically have a basic 3D shapes renderer. Right, we'll just copy. So copy debug draw 3D, but make it work on the mesh passes in the mesh render layer buffer thing. render pass, right? So we can just put a bunch of basic shapes down, and then it also works for transparency. So it will work for transparency. Then the final thing would be, oh sorry, the other thing would be hot reload working properly on CPU code. Right, currently crashes most of the time due to some weird reason. And another one is like, how do we do game code in this engine? Right, is the game the exe or a library? Right, is it a framework? Right, you know, what do we do, right? And what else? Oh yeah, we probably want to get, you know, make CPU side code compile super fast, right? You know, we'll just sort that out. Find the easiest piece of low-hanging fruit, basically sort that out. It's not slow, but it could be better. We want to make it better. We want to spend a little bit of time, just a little bit of time doing that. And I think okay. I think that's in a good place. But yeah, once we have these addressed, we should be able to get prototyping on a game idea, basically. So just go all in on trying to make game prototype and make game fun. And then we'll come back to the sort of engine renderer and make game look good. Right, so we'll try and basically, so the plan is, right, so this is the prerequisites. Right, these things. The sort of plan, the general plan is make game prototype that is fun, right? We want it to be networked, if you will, between two players, probably. I think network between two players, maybe. And we also would like which is fun. Right, so what does this mean? This means like basically the main game loop, main game loop, you know, so a fully playable game you would call this a vertical slice, wouldn't you? I think fully playable game, but not all the content, right? You know, and obviously programmer graphics, if you will, right? And then obviously, go back to renderer. Okay, that's the plan. Okay, right. So next stream, if we check on Twitch, there's a schedule down below. Next stream Friday, 2 p.m. GMT +1. There's a stream on Sunday, Tuesday, and Thursday at 7:30 p.m. GMT +1. But yeah, thank you everyone for coming. Appreciate you all. And yeah, God bless you all, guys. And I'll see you all hopefully tomorrow. If not, have a good weekend. And I'll see you in a few. Bye.